So good morning, friends. This is Durga again from IT Varsity. Today is the last class for Big Data Engineer Immersion course, and we will continue where we left off yesterday. We are in the process of setting up the lab, and uh, uh, as we stopped in the middle, we lost all the settings we have chosen. So I'm starting from scratch again. I will quickly come to the point where we stopped yesterday, and then we will proceed further. Before that, people on WebEx, please confirm that you guys can hear me and see my screen so that I can move on. Okay, let me confirm from YouTube also. Yeah, it looks fine. So I will start. Again, I'm doing from the beginning after setting up MySQL and setting up the local YAM repository and installing Ambari server. This is the first thing which we will do. We will start configuring the cluster, and then installation will be done. So the cluster name is HDP. Here we have to use local repositories. So choose use local repository, and whatever repository you want to download, you have to choose that one here. So in this case, we are trying to set up HDP 2.5. So we need to have local repository of HDP 2.5. Otherwise, it will fail. And our OS platform is Red Hat 6. So I'm keeping that one and removing all the others. Okay. And then I have to give the URL. So here I'm logging into the node. To get the URL for the HDP local repository. Instead of connecting publicly to instead of connecting to the public repository, I am trying to connect to the local repository here. So I need to get the URL. So we need to give both base URLs of HDP of both HDP and HDP utils. So HDP is this one, and HDP utils is this one. And then click on next. We have to get the private key. Okay, and we have to give the host names here. I can say hdp00204.itversity.com. So before getting into this, as I have explained yesterday, you have to do the capacity planning about how many nodes you should have in the cluster, how much storage you should provision, and then you have to decide what all services to begin with. You don't need to install all the services that are available out of the box along with HDP. You have to decide the services beforehand itself, and you can choose only those things which are required for you. No need to select everything. For example, in most of the Hadoop clusters, HBase is not typically installed, so we can deselect HBase when it prompts to choose the services. And before going to choose the services, you need to make sure that all the warnings are addressed. Either you need to have a proper answer for those things, or everything should be in the resolved state. You should not even see the warnings. Otherwise, you will see some surprises later. Okay. In this case, most of the errors are because our warnings are because I have tried setting up several times on these machines. That's why it is giving those errors. Typically, on a clean slate, you will not see those errors or warnings. Those are all warnings, not errors, though. So in this case, I don't want to set up HBase, Falcon, Storm, Flume, Atlas, Kafka, Knox, SmartSense, Mahout, and Zeppelin. I don't want to set up those things. And then click on next, proceed anyway. The first thing is you have to assign the masters. Actually, if you follow this order, you will understand what we are trying to do. So first we confirm the hosts. So all the hosts has to be ready. Then we have to choose the services, assign masters, then it will take to slaves and clients. Okay. In this case, I want to set up name node on HDP00, secondary name node also on HDP00, resource manager also on HDP00, the way we have planned yesterday. Let me open the form here, a sheet which I have filled yesterday. Let me choose everything HDP00 here. And Zookeeper, we only want to set up on one node. Typically, it is set up on 3 nodes, but in this case, as we don't have many servers, we are only setting up on one. Okay, and then matrix collector is also should be on HDP00. Not this one. Now let me go to the sheets and choose the capacity planning here, or cluster planning. Okay, and here click on next. So we selected as per yesterday's planning. Everything will be on 00 itself. Okay, and Spark Thrift Server, I want to choose all. Clients also I want to choose all. You should not have data nodes and name nodes on the same servers in production. Name nodes has to be separate. All the masters has to be separate, and all the worker nodes are separate. In our case, 1, 2, 4 are designated as worker nodes, and 0, 0 is the only one which is designated as master. Hence, it has selected all the slaves properly. If not, you have to review and make sure that it is configured properly. If by mistake, if it choose one of the server which you want to designate as a gateway only or as a master in future, you have to deselect those things. You have to spend good amount of time in reviewing these things and make sure that you are doing it correctly. And then click on next. And we stopped here at customized services level. First, we will fill the mandatory stuff, and then we will come back to the most important parameters which will determine your cluster capacity. So first thing is, okay, I have chosen accumulo also today. Yesterday I didn't choose accumulo. We will just set some random password here. Again, for accumulo also, we are trying to set up an account. That's why it is asking for password and also confirm password. That is done. And then Ambari metrics. Even in Ambari metrics, Grafana is a web application, and we are trying to set up the credentials for the Grafana web console, the admin credentials for Grafana web console. So here also just set up the account by passing the password. Whereas when it comes to Hive or Woozy, we are trying to connect to the existing MySQL database for Hive Metastore and also for Woozy server. So here you need to make sure whatever credentials you are entering here are in line with whatever you have mentioned while setting up the environment. Okay, so here we have to choose existing MySQL database, and it's already we ran this, so we don't need to run this. And our database name is Metastore. Username is hive_user. Password is ITversity. Click on test connection. It will validate whether your database is whether the credentials are valid or not. Okay, there is some, I think username is just Hive, not Hive_user. Okay, now the connection is okay. And now go to Uzi. Here also it's existing MySQL database. Database name is Uzi, username is Uzi, and password is ITversity. Text connection. Okay, so now mandatory settings are done, but this is not good enough to set up the cluster efficiently. You need to review, you have to spend good amount of time at this stage. You need to review some of the important parameters to make sure that your cluster is configured appropriately. So the first thing is the directories, name node directories, data node directories. These two, more than name node directories, data node directories are important. Uh, but when it comes to name node directories, more than the capacity, the resilience and fault tolerance is more important. If you recollect the HDFS concepts, I have spoken about metadata, and metadata is stored in memory component called name node. And for recovering, if the name node goes down, because it's an in-memory component, if it goes down, if you have to recover, there are a couple of file structures called fsimage and edit logs. I hope you guys remember that. So those fsimage and edit logs are nothing but file structures, and they should be a means you have to assign a file system for that, and that file system has to be configured with RAID. Okay, because if something goes wrong for one of the hard disks on which your name node metadata is stored in the form of fsimage and edit logs, still you can recover transparently without having any impact on the cluster. For that reason, the name node metadata, whatever file system you choose to store, has to be configured with RAID, so that you are safe even if some of the hard disks fail. And when it comes to data node, you have to use something called JBOD. Let me go here. So for HDFS, you have a file system for name node, which has to configure with RAID. Okay. Here we are not doing, but in production you have to do that. And when it comes to data nodes, you don't need to configure RAID. RAID is primarily to address the hard disk failures. There is something called RAID mirroring and RAID striping, and different RAID levels are there. If you do RAID mirroring, then even if half of the hard disks fail, still you will not have any impact on the applications which are using that file system. And if you use RAID striping, it depends upon the striping level. Anyway, I don't want to get into too many details here. Make sure name nodes are configured. The file system for name node is configured with RAID. 1 minute, okay. And then the second portion is data nodes. For data nodes, you need to you will come across this word called JBOD, which stands for just a bunch of disks. So which means that there won't be any RAID configuration or anything. You just install the hard disk on the server, and you will start using that. Nothing else, and no RAID, nothing. So for data nodes, we just need to use as is. So for data nodes, we call it as JBOD. Okay, so what you need to do is when you actually provision the servers to set up the environment, at the time itself, you have to do capacity planning properly, and you need to have at least 2 or 4 hard disks. You should not just have one. You need to have more than. It all depends upon how many CPUs you have and what amount of memory you have. Typically, you will have either 2 terabytes or or 4 terabytes or 8 2 terabytes, or whatever it is. It all depends upon number of CPUs you have, number of IO channels the server have, etc. You have to work with system admins closely and come up with proper configuration. Okay, and then in this case, I'm coming back to HDP00, on which I want to set up name node. Okay, and you can run df command df-h to read in human readable format. You see, I have something called volume groups and logical volumes. So logical volumes are logical file system out of the existing hard disks. You should not use these logical volumes or any logical stuff when it comes to data nodes. In this case, just to set up the cluster we are using, but in real world scenario, you just have to install the hard disks and you have to mount directly, format as is without creating any logical volumes, and then you have to start using those things. So in this case, as we have only one file system, it picked only one directory, and it is not a mount point, it is just a directory. So if I do, if you look into here, there is no mount point for Hadoop HDFS data. But in actual production clusters, you will have multiple mount points which will be there on each server, and all those mount points will be mounted to a set of directories with same naming conventions, and those mount points should be used for HDFS. You should not have your operating system and your data in same hard disks in the form of logical volumes. Instead, you need to have small amount of storage for OS and others, like 32 GB or 64 GB, whatever it is. And then your actual multi-terabyte hard disks should be mounted directly and onto a directory structure, and those should be used here as data node directories. Typically, we will have the number of entries here. Now we have only one, whatever I have selected. In production scenario, it depends upon how many hard disks you have. Those many entries you need to make here, and automatically HDFS is smart enough to use all those directories to store the data. Okay, so that way you will the IO will be much more effective than creating logical volume groups or having fewer larger disks. It's better to have multiple hard disks depending upon the number of IO channels you have and the amount of parallel IO you can do. So there is a question here. So each data node is a separate physical machine. If it is so, in 100 node cluster, we will have 100 physical nodes. Am I right? That is correct. That is absolutely correct. If it is a 1000 node, you will have 1000 physical nodes. If it is 4000 nodes, you will have 4000 physical nodes. And most of the success stories are on physical machines only. You can use virtual machines also for practice and development purposes, but it is not commonly used to set up Hadoop on virtual machines, except on Amazon. Amazon EMR, Elastic MapReduce, runs on Amazon EC2, which is nothing but virtual machine. But there, the performance will be a little bit less compared to physical servers. But people use AWS because it's a lot more cost effective. That's why people use AWS EMR. Otherwise, in most of the organizations where they don't use any cloud services, they don't use virtual machines. Okay, so that covers the storage part, and then the CPU and memory. CPU and memory is the one which will actually determine the capacity of your data processing. Okay, so here I am again trying to do some planning here. Let me add new tab, memory tuning or memory configuration for Hadoop. So one of the article which I will recommend you to go through is once you gain some functional knowledge all the basic knowledge about Hadoop, uh, uh, I will recommend you to go through this article. You can search for Cloudera yarn tuning. If you can understand this article, that means you can confidently say that uh, you can actually plan the cluster um, efficiently, okay, with confidence. So here, let me take the settings here itself. So you can see that for as part of the step one, they're talking about worker host configuration, okay. And when it comes to worker host configuration, this is the capacity of each of the worker node, okay. So each worker node, they are taking the example of having 256 GB RAM, okay, 256 GB memory, not storage, it's memory. And CPU is 48, which is 8 CPUs, 6 cores, means 8 hexa-core CPUs. That means that server have 48 cores, which is similar to 48 CPUs. And HDD, hard disk drive, here you can see there are 12 hard disks with 3 terabyte storage, and all the hard drives are in JBoard configuration, and Ethernet is 1 gigabit Ethernet. And there are two because even if I think it is only to provide redundancy, so that even if one Ethernet cable is gone, still your cluster will not have any impact. It's just to have the redundant networking. Okay, so here we take the server with this configuration, and then at each server level we are talking about. So if we have 10 nodes, on each of the 10 node has to be consistent. They have to have the same configuration unless you are in the process of upgrading your cluster. When you are in the process of upgrading your cluster, you will take the partial cluster, upgrade it, and then go to once this the first set of the first set of nodes that are part of the partial cluster are upgraded, you go to the second set of nodes. That way you do the upgrade, and when you are in the upgrade process, some nodes might be at higher configuration and some nodes might be at lower configuration. But in day-to-day business in day-to-day business as usual scenario, each and every node has to be consistent and same. Okay, so what you need on a host, you will start with the operating system, and you have to allocate memory to operating system. Here it started, it's a 256 GB server, hence we are allocating 8 GB RAM. On a 32 GB server, we don't need to allocate 8 GB. 8 GB is the max. After 64 GB or 128 GB, irrespective of the size of the server, for operating system, 8 GB is more than enough. But on a smaller cluster, you should not say 8 GB is 8% of 128 GB. Hence, I will use 8% on the smaller size cluster. That is not the case. If it is 32 GB server, still you have to give at least 4 GB. If it is 16 GB, still you have to give at least 4 GB to the operating system. But you can cap at 8 GB once you cross certain threshold, like after 64 GB, you can use 8 GB safely for any size server. Okay, so operating system, we are allocating 8 GB. And then on each of the node in the cluster, we need to run agent. And what is an agent? Agent is nothing but a software process which will be up and running all the time. To keep it up and running all the time, you have to allocate memory and you have to allocate CPU, right? That's why we are allocating 1 CPU here and 1 GB RAM for the Cloudera Manager agent. Okay, so this is only the planning, and you have to assign the settings later as per this planning. Okay, and other services, if you have any other services, for example, there will be some services that will complement your HDFS cluster. If you are trying to use big data system for email campaigning, you need to have an email server configured, and you should your MapReduce programs might have to send emails to the recipients of the emails. In that case, you have to set up email server on all the nodes in the cluster, which needs to be included as part of the planning. So other services, email service is one of the example. If you want to, for example, encrypt and decrypt using some third-party tools which works with Hadoop, you have to work with them and determine how much memory should be allocated and how many CPUs have to be allocated for their agents that will be running in the cluster. So any other service that will complement the big data system, you might have to set up and manage it, and you have to plan for those also. And other services cover that part. In this case, we are not setting up any other services, hence 0 CPU, 0 memory. And then HDFS data node. Again, data node is nothing but a software process which will do few things. It will keep on sending heartbeat to the name node, saying that the data node is live and it can take some of the data. It can take the data when someone tries to copy data into HDFS, and also it does few other things. So data node is a software process which needs to be up and running all the time. Hence, we need to give some some memory and CPU to that. That's why we are giving 1 and 1 GB. If you are writing too much of data, probably you might want to give a little bit more memory, but 1 GB is, and 1 CPU is more than enough for most of the cases. Okay. And then if you want to set up Impala, we are actually working on Ambari cluster, so we don't have Impala out of the box. If you want, we can set it up. But if you have Impala and if you want to configure it, you have to plan for its CPU and memory. And there is a reason why you have to do this. So let me get the whiteboard let me get the whiteboard to reiterate the architecture and dependencies of these Hadoop components, so that you understand why we have to allocate memory for some components while explicitly, while we don't need to allocate for other components explicitly. I will explain that. Let me get the whiteboard. I am connecting the whiteboard and I will start in a moment. Okay, so now let me start the essentials. Okay. So if you recollect, when it comes to the big data ecosystem, you have HDFS at the bottom. Sorry, let me erase this one. I am very bad at drawing and handwriting, so bear with me. So this is HDFS, which is the file system when it comes to storing data in Hadoop based big data cluster. And then it is nothing but a file system. And then to process the data, you have MapReduce based tools. You have Spark based. You have HBase. And you have others like Impala and many more. There are many technologies which sits on top of HDFS to process the data. Okay, so MapReduce and Yarn can be controlled by, sorry, MapReduce and Spark can be controlled by yarn. Okay, so when it comes to a particular technology that is supported or managed by yarn, you don't need to so whatever memory settings you are trying to do, these things has to match with the yarn memory settings. So MapReduce and Spark can be managed by yarn. So whatever memory settings you set up for MapReduce and Spark has to be in line with the rules that are set up with yarn. Whereas HBase and Impala, they are different. Okay, HBase is managed outside of the yarn, Impala is managed outside of the yarn. So when we actually plan for yarn, we are actually planning for MapReduce and Spark inherently. We don't need to explicitly say how much memory should be given to MapReduce or yarn, as long as MapReduce or Spark, as long as they are managed by yarn. If Spark is managed by Mesos, then you have to plan a little bit differently. Okay, in our case, MapReduce and Spark are managed by yarn. So from memory settings perspective, when we do the planning, it is enough to plan from yarn. Once we plan from the yarn perspective, then if you want to allocate the memory and CPUs that are allocated to yarn to processing frameworks such as MapReduce and Spark, you have to distribute those settings. For example, let's say on each of the node we want to use 40 CPUs or 40 cores and 30 GB memory for yarn. Okay, when we actually go to the go a little bit deeper and start setting up the settings for MapReduce and Spark, we have to make sure we satisfy this 40 cores and 30 GB together for MapReduce and Spark. If you overallocate one, if you overallocate the if the memory allocated for MapReduce and Spark is more than 30 GB, but yarn is capped at 30 GB, then there is a probability that it will run into some out of memory issues and all those things. So you need to understand this dependency. HDFS is independent, it's just a file system. When it comes to processing, we have multiple processing frameworks: MapReduce, Spark, HBase, Impala, etc. MapReduce and Spark can be managed by yarn. So we need to start with yarn with respect to setting up memory and CPU for MapReduce and Spark. For others, HB and Impala, we have to explicitly say, explicitly tell how much memory we want to give. And altogether, if you recollect, we have 256 GB RAM and 48 CPUs on each of the machine. Altogether, MapReduce, Spark, HBase, Impala, altogether it should not exceed 256 GB RAM and 48 GB, 48 cores. Okay, the cap is your server level memory and CPUs. That's the overall cap, and then you have to drill down and distribute across all the components you are trying to set up on the cluster. Okay, any question here? If you have any question, you can ask, and I will be glad to respond. So here, Impala is not managed by yarn. That's why there is an entry saying Impala daemon. And if you want to set up Impala, you have to do some capacity planning. You have to go through the Cloudera documentation. The recommendation is to allocate at least 16 GB memory when using Impala. Impala is memory intensive, like Spark. Hence, if you want to use Impala, you have to allocate 16 GB on each of the node. That is at least. And depending upon the amount of usage, you might have to jack up the Impala. If the more memory you allocate to Impala or HBase or Solar, these are all big data components which can be set up on the cluster. The more memory you allocated to those things, the less memory that will be available for yarn, and the less memory that is available for yarn, less memory for Spark and MapReduce. So all these are dependent. Okay. So we are not setting up Impala daemon, we are not setting up HBase, we are not setting up Solar. So hence CPUs and memory are 0. And when it comes to yarn, if you recollect, on each of the worker node, when we set up yarn and HDFS, So this is our server. You start with OS. First you will set up OS. Then you will set up data node. These are all software process. Okay. So this is OS. This is data node. And then node manager. These will be there all the time. And all the process that are to run your OS has to be up and running all the time. All the process, software process on each of the node, software process on each of the node to support your HDFS, which is data node, has to be up and running all the time. Node manager, which manages your mappers, reducers, Spark executors, etc., has to be up and running all the time. Hence, we have to allocate memory and CPU for all this software process. That's what we are trying to do here. We have allocated CPU and memory of 1 CPU and 8 GB for operating system, 1 CPU and 1 GB for HDFS, and 1 CPU and 1 GB for YARN node manager. This is for the node manager, not for the tasks that will be running. Okay, now you have given 8 GB for operating system, 1 GB for Cloud Manager agent, so 9 GB is done, and then 10 GB with HDFS and 11 GB with YARN. Out of 256 GB, we have allocated 11 GB to rest of the components here. If you have Impala, if you give 16 GB to that, then you have allocated 27 GB, and you have to subtract from the overall capacity of the cluster, which is 256 GB. In our case, it's 11 GB because we are not setting up Impala, and 256 GB minus 11, which is 245 GB. And if you calculate 245 GB into 1024, this is the MB number. Okay, and this is the available memory for YARN. Now we are done with memory settings, memory planning, and second level of planning is about CPUs. 1 CPU for operating system, 1 CPU for Cloud Manager agent, 1 CPU for HDFS data node, 1 CPU for node manager. So 4 are done. We have 48 as the capacity. 48 minus 4 is 44. So available resources are 44. And now you have to determine whether your cluster is cluster will be used for CPU intensive or standard IO bound. Okay, if they are standard IO bound, then you can increase the vCore multiplier to 4. If it is CPU intensive, then you have to use it 1. So in this case, if it is CPU intensive, ARM available vCores are only 44, but we are considering it as IO bound. Hence, we are multiplying with 4. There is a reason why we are doing this. If you know the basics of how operating system work, so any processing happens when the data is in memory. Okay, first you have to do IO, get the data into the memory, and then apply the logic on that. And when the logic is being applied, then CPU will be used. Otherwise, CPU will not be used. So when we say CPU intensive tasks, that means you have to focus a lot on processing the data, applying the logic and process the data. When IO is done, CPU will sit idle. If you know the fundamentals of operating system and how all these CPU, memory, all these things work, when IO is being done, your CPU will be idle. IO channels are the ones which will be performing the IO. Once the IO is done, whenever the processing needs to be done, then only the CPUs will kick in and it will start processing the data. So in case of CPU intensive tasks, your IO will be minimal, but CPU has to be up and running all the time. If there is a contention for CPU, what will happen? The CPUs will go to the applications will go to sleep mode until they get their chance in some algorithmic fashion. It could be round robin, it could be something else, it could be some priority based, whatever it is. Until the application gets its turn, it will go to sleep if there is a contention for CPU. So the reason why we are saying 1 for CPU intensive tasks is that your CPU should not go to sleep at any point in time. In case of IO bound, your CPU will not be used, hence it will be automatically in the sorry, it's not the CPU. Your application should not go into the sleep mode at any point in time and waiting for CPU to execute the application logic. That's the main idea. Your application should never go to sleep. In an IO bound, CPU will be available all the time because your cluster will be busy doing IO using IO channels, not the CPU. Hence, as CPU will be available all the time, your applications will get their fair chance whenever they are executed because it is not CPU intensive. But when it comes to CPU bound, CPU intensive, IO will not be done that much, and CPU has to be used to execute the data. And if you increase the multiplier higher than the if you increase the multiplier and if the result is much higher than whatever number of CPUs, physical CPUs you have, then applications can go into the sleep mode if you are trying to perform CPU intensive tasks. So you need to understand why we are doing this multiplier, physical cores to V cores multiplier. It's for CPU intensive tasks, it should be 1 or 2. It should not be more than 2. For IO bound tasks, it can be 4 or 5, whatever number you want. Again, you can understand the pattern by observing after the cluster is set up and after the application started rolling in, and then based on that you can change these settings any point in time. But to kickstart in the beginning, you can make certain assumptions based upon your planning, and you can start with whatever number you determine is feasible. And then if you run into any issues, you have to come back and make sure you revisit these things so that your applications run effectively. Okay, so here the multiplier is 4, hence we have 176 V cores and 245 GB memory, and these are the settings which we these are the things which we use to set up the cluster. Okay, now going down, we have number of worker hosts in the cluster as 10. So the overall capacity of the cluster is 176 into 10, which is 1760 CPUs, virtual CPUs, and 250 GB into 10, which means 2.5 terabytes. So you have 2.5 terabytes of memory available for yarn and 1760 virtual CPUs for yarn, available for yarn. So now you have to go to so we will come back to the parameters a little bit later. So this is the number which we have, which we can use to for the data processing to run our MapReduce jobs or Spark jobs, etc. Now let us get into the parameters. So again, if we go back here, we started with operating system. At the time of setting up the operating system itself, we will take care of setting up the memory. To set up the agent level configurations, typically there will be a INI file. Okay, again, you have to go back to the documentation and determine which file should be used for this Cloudera managed agent or Ambari agent. But typically there will be a INI file. So let me see if there is any etc Ambari agent ls-ltr. Yeah, there is a conf directory here. Okay, you see INI file here, Ambari agent.ini, and this is the place where you set the memory settings for your Ambari agent or Cloudera agent. For Cloudera also, I think it is INI file itself. I do not remember on top of my head. You can go to the documentation and you can determine how you can set up the memory. Okay, most likely this is the place where you set up. By default, it's 1 GB, and I think it is more than enough in most of the cases. Okay, and then HDFS data node. That's again, now you have to come back to the and this whatever I'm explaining, you have to do it beforehand itself. By the time you come to this page, you should have a spreadsheet in which it says, set this setting to this much size. Okay, you should not wait until this point and then do the planning. You have to spend enough amount of time in planning and then review the settings in such a way that the settings are as per your plan. Okay, so here when it comes to worker node, you have data node maximum Java heap size. This is the parameter which will control the data node memory size. If it is 1 GB as per your plan, it should reflect here. If it is 2 GB, you have to change it to 2 GB. Okay, and we only spoke about worker nodes because that is more important. When it comes to name node or resource manager, there are very few settings which you need to remember. One is name node Java heap size. So name node Java heap size is the one which will actually store all your metadata in the memory. Okay, and typically if you have 256 GB RAM for a name node, you will allocate most of the memory to that. Whatever the memory 245 GB that is outstanding after giving it to Cloudera agent or Ambari agent and operating system, whatever is the remaining, you have to give it to the name node Java heap size. But when it comes to data node Java heap size, it by default it's 1 GB. If you want to change it as per your plan, this is the parameter which you need to set. Okay, and when it comes to the parameter name or the location, the parameter is actually in. If you go to, because HDFS and MapReduce are Hadoop components, both HDFS and MapReduce settings will be available as in this directory. In this directory, you will have files. Okay, because I ran already on this cluster, that's why I'm seeing these files. You will not be seeing these files at this step. Okay, so if you go to this location and there is Hadoop env.sh, all memory settings are typically in this file, but you should not manipulate these files. Instead, you have to use the web interface to set these things. Okay, and when it comes to data node directory, after setting up all the mount points, you can go to so this is the place where you update in the web interface. If you have to do it from the background, you should not do when the clusters are controlled by the management services. But if you want to review, you can actually go to hdfs.xml and search for data.dir and it will reflect here. Okay, so this takes care of HDFS memory settings, and then you have to go to the ER. Okay, in this case, each of my node is only 6 GB. Okay, and I have given one. I didn't do any planning. I am accepting all the default values. Even in your case, when you go here, it will take some default values based upon your cluster size. You have to review and make sure that the values are reflecting as per your plan. And on 256 GB server, first thing is this parameter. One minute. Okay, yeah. So this parameter is not the node manager memory parameter. Okay, let me see where that node manager parameter is there. Somewhere it should be showing up. So what I'm trying to show you is, if you go back here, so ER node manager, we have to allocate this 1 GB. I have shown where the data node 1 GB is allocated. For the ER node manager also, we have to allocate 1 GB somewhere. I am trying to search for that setting. Just give me a moment, I will figure out. Yeah, this is the one. Node manager Java heap size. It is under the advanced settings. Okay, the 1 GB which is reflected here is set up here. So we are allocating 1 GB to this. As my cluster is not very big, if I want, I can reduce it to 512 MB also. There is no harm in that. So on each of the node, Node manager will be running with 512 MB if I change it to 512, but by default it's 1 GB and I'm leaving like that. And most importantly, the ARN settings will be reflecting here. If you recollect the planning, we have 176 virtual CPUs and 245 GB memory. Okay, and those settings have to be reflected here, especially the memory. Not, we don't explicitly say CPUs anywhere. We will only talk about how much memory should be allocated. Here, in this case, we are trying to allocate 245 GB. If it is 256 GB worker node, so you have to change those settings here, and that will take care of ARN settings at a higher level. But when you submit some job, whether it is a Spark job or MapReduce job, the data will be processed in the form of containers. So if it is MapReduce, the container will contain map task, reduce task. If it is Spark job, the containers will contain Spark executors. So depending upon the technology which you try to use to process the data, the container will be executing that component. So to set the limits on those container settings, there are two parameters. One is minimum container size and the other one is maximum container size. Okay, so this is total memory. So in this node, I'm trying to use 3 GB for node manager to submit MapReduce jobs or Spark jobs, because those two are the things which are controlled by YARN. And these settings for each container, we are going little to a little bit lower granular level compared to here. This is higher level and this is a little bit lower, next level. So we are setting certain limits, saying that okay, any container that is managed by YARN has to be within this range. So now going back to this, so what Cloudera is saying is, so these are the parameters which control vCores, and these are the parameters which control the memory. So this is CPUs for your containers, and this is memory for your containers. So minimum is 1 GB and maximum is 8 GB. And then if you have to increase, you say increase it by 512 MB. So minimum allocation MB, maximum allocation MB, increment allocation MB. So when we actually configure MapReduce or Spark later, whatever settings we give for map task or reduce task in MapReduce, those settings should be in line with whatever settings we have done at YARN level. YARN is higher level, MapReduce and Spark is lower level, and YARN controls how much MapReduce and Spark can be configured for, so that YARN is aware of how much memory is used by MapReduce at any point in time and how much memory is used by Spark at any point in time, and make sure that the application that does not run into out of memory issues and all those management related issues. Okay, so these container settings are primarily to set what is the minimum size and maximum size for the underlying components that will actually process the data. If it is MapReduce, the components are map task and reduce task. If it is Spark, the components are Spark executors. Okay, so here if it is 256 GB cluster, we can consider these things: 1 GB for minimum container minimum memory and 8 GB for container maximum memory, and 1 CPU for container minimum CPUs and 32 for maximum CPUs. Okay, all those things has to be reflected here. So these are the parameters which will control those things. Okay, and then we have MapReduce and Spark here. Once YARN is configured, we have to review MapReduce and Spark. Go to the MapReduce to understand what is happening in the MapReduce. And here you can see what is the map memory and what is the reduce memory. Map and reduce are nothing but containers from the YARN perspective. So whatever settings we give here, it has to fall within the range of minimum memory and maximum memory, minimum CPUs and maximum CPUs. Okay, in this case, map memory we have allocated 0.75 GB, and reduce memory we have allocated 1.5 GB. And if you go to YARN here, for YARN, the minimum is 768 MB, and maximum is 3 GB, right? And when it comes to map reduce, the same amount of memory, whatever is allocated minimum as part of the container size is taken by map by default. If you want to change it to 1 GB, you can change it over here. And then reduce memory, you want to play, if you want to play with it, you can play with it also. But in our cluster, we have to keep within this range 1 GB and 8 GB. Typically for mapper, we either give 2 GB. We typically give 2 GB. In some cases, we give 4 GB. For reducer, whatever memory you have given to map, we will try to do 1.5 times than that. So if it is 2 GB for mapper, it will be 3 GB for reducer, because reducer does sorting and joins, etc., which are a little bit memory intensive and also CPU intensive. And also typically reducers will be fewer compared to mappers. For that reason, the capacity to the reducer is typically 1.5 times to the mapper. But you can change it depending upon the behavior. If you have to increase or decrease the ratio, you can do it. And this is the location where you play with map memory and reduce memory. Only thing you need to remember is the map memory and reduce memory that is being allocated has to be in line with the minimum and maximum container memory at the YARN level. Similarly, is the case with app master. App master is also another task that is managed by container. If you recollect YARN architecture, or MapReduce jobs that are running in YARN, for each and every job, an application master will be created on the server where node manager is running, and that will take care of the life cycle of the job. So it also have to have CPU and memory. And these are the settings which will control those things. Okay. And if you want to allocate CPUs, I think you can go to the advanced setting and you can play with those things also. Somewhere here. Let me see. I think you cannot directly set CPUs here. Only memory can be controlled in MapReduce. Whatever settings we have given at YARN level will be inherited for MapReduce. But to override, I think you can set certain parameters on per job basis. Okay, and then we also have Spark that is being controlled by YARN. Spark is a little bit complicated because it is not very well integrated as MapReduce 2. So you have to search for those parameters which are relevant for the memory. I think it will be under Spark env, and you have to update whatever settings you want to use. And those settings also have to be in line with the ranges that are set at YARN level, as long as Spark is controlled by YARN. I'm not 100% sure about the parameter names. It will be either in Spark defaults or in the Spark env. You have to explore what are the relevant parameters and you have to set those things. Okay, so this is how you actually set the memory settings and MapReduce memory settings for HDFS, YARN, MapReduce, Spark, etc. when planning for your cluster or when setting up the cluster. So now I am taking you to the CloudX lab. If you go to CloudX lab, and go to YARN, go to Quick Links and Resource Manager UI. Okay, now you see memory total and vCoast total. So this memory total and vCoast total will be reflecting because of parameters, these two things. YARN node manager resource.cpu. For each node, we will be setting these values. for this configuration, which is 176 and 245 GB. If there are 10 nodes in the cluster, these are cluster level details. Okay, so if you really configure with 10 nodes of 256 GB with those memory settings, then memory total will be 2.45 terabytes, and vCores will be 1760. It will reflect the actual cluster capacity. And number of mappers and number of reducers, number of Spark containers that can run at any point in time is determined by the other memory settings, which can be overridden at runtime. So even though when it comes to MapReduce, we set the settings of 1 GB for map memory and 1.5 GB for reduced memory while setting up the cluster. If they are not final, we can override these things at runtime. Okay, so as we can override these things at runtime, the capacity is not static; it will change. So, for example, we have let's say 1760 vCores. Okay, and if we say each task can take up to 4, in that case, forget about memory for now. Let's say each task can take 4 CPUs. In that case, at any point in time, 440 tasks can run simultaneously. If we say each task take 10 CPUs, then only 176 can run simultaneously. So the number of tasks that can run in parallel is determined by at runtime, depending upon how people are trying to use the cluster. Okay, so that's the flexibility given by YARN. They can change the memory settings at the time of runtime. There is no predefined number of mappers or reducers that needs to be set. It all driven by the capacity that is being used by the underlying components. And this flexibility comes with some complexity. So whoever is trying to manage the cluster, and also whoever is trying to run the applications on the cluster, they have to be knowledgeable about these things and understand the impact on the cluster with their decisions, and they have to be extremely careful when overriding these parameters. Otherwise, they will run into many surprises and the cluster will become unmanageable. Okay, so that's about how the number of mappers or number of reducers or number of containers to process the data can run simultaneously when the cluster is managed by YARN, especially the data processing stuff. Now I will go back to here to these pictures so that you understand what these pictures actually represent. So you have a host with memory and vCores or CPUs, right? And a container can be of any size. It can be up to this memory and up to this cores, or it can be up to this size and up to this cores. It can be anything. So if you go back here, you can see it here. So this container have vCores up to this and memory up to this, and this container have memory up to this and vCores up to this, and this container have a different configuration. So the reason is, I will come back to that question in a moment, Jiva. Let me complete this. So the reason is, whenever we run the MapReduce job or a Spark job, at that time we can tell what is my map task size should be and what is my reduced task size should be, how much memory should be used and how much CPU should be used. And based on that, one MapReduce job is trying to use container of these sizes, of this size, and other MapReduce job might be using containers of this size, and a Spark job might be using containers of this size. So ultimately the impact will be the number of containers that can run in parallel will change at any point in time. There will be no static number. Okay, so this will give you much better picture. There are containers of different sizes that are running at any point in time. Okay, so now they are actually giving the terms to it. So these blue things are MapReduce containers, and other ones are could be Spark containers or any other technology that is being managed by YARN. Okay, So this is how you can interpret this blog. It's very important for you to understand this blog so that you can actually plan your cluster in an effective fashion. So the now question is, could you please repeat the calculation, whether it's CPU or cores? It's interchangeable. CPU or cores are interchangeable. If you really understand the terms they use, they say quad core CPU, which means that there's a CPU which have 4 cores, which is nothing but 4 CPUs, or 4 CPUs, but comes with part of one hardware component. Okay, in this case we are using 8 hexa-core CPUs. Okay, which means 8 CPUs which have 6 cores in each of them, which are 48 cores, and those 48 cores you can consider them as virtual CPUs or virtual cores, whatever it is. The terms are interchangeable. Okay, but CPU is more of a physical in nature, and cores are component of CPU, which it acts as CPU itself. And vCPUs are virtual CPUs, which we tend to use while configuring the cluster. It's all about terminology. Okay, in the end, it's nothing but a processor. Whether you use CPU or core or vCPU, all are nothing but processors. Hardware processor, not the software processor. Okay, so now once you make sure you configure the memory settings properly, you can click on next after making modifications to all the mandatory settings, and you have to do this exercise for each and every component. Now you preview, you are setting up data nodes on 4 hosts, name node on 1, secondary name node on 1, and app timeline, node manager, resource manager, and blah blah blah. You go through all the components and then click on deploy. So here it will take time. So actually it is faster for me because I have already set up, and most of the components might be already there or cached on the servers. So I will highly recommend you go through these things and make sure what is going on behind the scenes, and it will give some clarity. The more you watch, the more you will understand what is going on behind the scenes. You will understand the dependencies and other stuff. So Kafka workshop. So my first priority is the lab. Okay, So most likely lab will be done by December second week. Once that is done, the first thing I will do is the Kafka workshop. I also didn't explore Kafka yet, and I want to get into that as quickly as possible. So that will be my first priority after setting up the lab. And if you guys are interested, I will make you moderator, and also I will make you the administrators also on the cluster, so that you will get much more expert exposure to the cluster. But you have to be extremely careful. You are feel free to go through the entire cluster and see what is going on. But if you have to stop and start, you have to be a little bit careful. I will give complete freedom to you, but you have to be a little bit careful. So whoever is interested in this student batch, and who is attending these WebEx live sessions to be moderator, all those guys will get admin access also to the cluster. And I will make the videos about how to troubleshoot the issues. I will make the moderators to the discussion forum, and I will make administrators to the cluster. And also I will try to make the videos how to troubleshoot the issues wherever you guys cannot resolve those issues. That way you will get to learn quite a bit over time by supporting all the all the subscribers who will be subscribing to the lab. And if I get enough subscriptions, I will give free subscription for lifetime for you guys whoever become moderators and whoever become administrators. If I am in positive and if I'm making good amount of money on the subscriptions, I will give free account as long as the cluster is available. So here there are some warnings. So you have to review those warnings. So it failed while starting a component called Grafana, but most of the things are successful. People go panic when they see the warnings. So what they have to do is they have to just click on OK, click on Next, and then understand what have been successful and what is not successful. Some of the services are not started successfully, and unfortunately Ambari will stop all the subsequent things. So after failing at Grafana level, whatever is needs to be started after that, they are not started. So you need to understand that, and you have to start those things manually. Okay, in this case Hive server and web hcat server are not started. So you can click on this one, Hive server 2, and then it will take to the node where the Hive server 2 is supposed to run, which is HTTP 00 in this case. You can click on this and click on start. Click on OK. Same is the case with Uzi. It also didn't start. It is because Grafana, Hive, Uzi, everything are running on the same machine, which is HTTP 00. Because Grafana is stopped, it did not proceed with any of the other components, and all the others also failed. Okay, now we have to start those things manually. That's the only thing which you have to take care. But when they are stopped in the middle, some of the sanity checks which it is supposed to do will not be done. So you have to make sure manually that your clusters is usable before start using it for your applications. So I'm starting all the things. They will go in a queue. First it is trying to start Hive server. Once it is done, it will start Uzi, then Accumulo, then web hcat. So we are almost done. You can click on this to see what is going on. If there are any others also, you will get to know. So it is trying to start the service. It will take some time. For some reason, it is stuck at 35%. I think it is retrying. Okay. Let's go to the dashboard and look into the others also. It failed with Grafana, but here it says it started. But in the other, originally everything got stopped because Grafana did not start. I don't know why it is taking such a long time to start Uzi. Ideally, it should not take this much long. And there is not much progress also, but I think first time it will take a little bit of time. Let's see. And also while it is starting, I will explain few other things. You should not see any of these orange icons. These are all kind of you have to restart because something is changed on the cluster from the configuration perspective. Because this is the first time and it stopped in the middle, before deploying certain things, components are stopped. That's why it is showing these orange circular arrows, and you have to restart all these services um, so that those circular orange circular arrows are gone. I don't know why. Let me kill this one. We will start it later so that we can progress. Okay, now let me restart all required so that those orange circular arrows will go away. And then we'll come back and start Uzi, and then we will review certain things. Again, you can click on this for the progress. I don't know why it is taking such a long time to start this matrix collector. Anyway, most of the other components are started, so we can actually review the other stuff like HDFS, yarn, etc. Okay, you can go click on Ambari and go to the dashboard. So HDFS, you don't see those circular arrows, but there are some alerts. You have to look into those alerts and see there are no critical alerts. These will go away automatically. As of now, they're okay, but earlier there was some critical errors on that. Slowly, those errors will go away. Okay, actually, data nodes are not started. You can see here out of 4 data nodes, only 1 is started. Others are not started for some reason. So we have to make sure they are started. Actions, selected host, data nodes, start, and click on OK. But for that, we have to complete this one. It is stuck here. I don't know why it is stuck with the matrix collector. Let me kill this one. Okay, let me take one at a time instead of running multiple things at a time. So let me start data nodes here. Okay, now data nodes are started. Go to Ambari, click on HDFS. Now 4 out of 4 are started. Then go to yarn, it looks fine. Map reduce, everything looks good. Now let's go to Hive and start the WebHCat server. Here the reason is, as we are running most of the master services on one server HDP00. So many things are impacted. In a truly distributed cluster, you don't see these many issues. There will be few issues when you set up the cluster for the first time, but there will not be these many. Again, it is saying 1 out of 4 data nodes live. So I have to click on HDFS. So data nodes are not coming up for some reason. I have to troubleshoot that issue. Okay. So data nodes are going down. So this is on HTTP 02. The way you can troubleshoot is go here, SSH root at HTTP 02, cd var log Hadoop HDFS, because data node are the ones which are impacted. Var log Hadoop and then HDFS and then tail -s. And let me do view. Go to this file and you can see there are some errors. So there is incompatible cluster ID. Okay, probably because, okay, the reason could be I set up the cluster earlier and I reset the cluster, but I did not do the complete cleanup. So whatever warnings I have seen, I have ignored those things. That is haunting me now. Ideally, those warnings should be addressed at the time itself, and then we should have proceeded. The primary reason why it is failing, why data nodes are not coming up is when I actually reset yesterday to set up the cluster, I did not delete the directories. So there are certain files in the backend which are causing issue. Okay, so there is no easy solution for it. I need to rebuild the cluster. Hence, I will wrap it up here. I will not get into further details. But bottom line is you have to make sure that all the services comes up. Other services are becoming slow because HDFS is not up properly. That's why Woozy and Accumulo are also struggling to come up. Okay. Anyway, that's not a bigger problem here. I have demonstrated how to set up the cluster following all the instructions. First, you need to get the do the capacity planning, provision the physical server, designate certain set of servers as masters and certain set of servers as worker nodes, and then once the operating system is set up on those things, you have to first start with the relational databases, or you have to use existing relational databases for your Ambari, for Hive, Woozy, etc. And then you have to start with Ambari server on one of the nodes. Once the Ambari server is set up, you will get a wizard. Using that wizard, you can set up Ambari agents, all the Hadoop components on the cluster. Once that is done, you have to make sure that everything is up and running, and you have to validate by running some HDFS commands, MapReduce jobs, etc. Once everything is smooth, then you can hand over the cluster to the development team or other stakeholders so that they start using the cluster. So you have to follow this life cycle when you decide to set up the cluster, whether it is for POC purpose or testing purpose or development purpose or even for production. Okay. So that being said, the same thing is done with CloudX Lab also. You already have access to this. You can use it, or you can also use my cluster, which is on Big Data Labs. As of now, it's only 2-node cluster, but over the weekend, I will make it a 5-node or 6-node cluster. And then slowly I will add more nodes beginning of the next month without impacting the cluster. But the current cluster might be taken down and you have to re-sign up, and you have to do some rework to if you already used the cluster earlier. That is with respect to Big Data Labs. So stay tuned. I will announce once the 5-node cluster is ready and you can start using it. And I will give you give all of you access. And means you just have to go to bigdata-labs.com and sign up for it, and you will get access to it. And also I will make you moderators, and I will also make you administrators to the cluster if you are interested. Okay. That being said, thank you very much for attending the complete course. We started with mostly developer related stuff, but as most of you are experienced guys, I felt it will add a lot of value to your learning process if I also demonstrate how the clusters are built. And you should aim for big data engineer type of positions. You have to do enough research in DICE to make sure what are the core skills they are looking for, understand the difference between the desired skills and required skills or mandatory skills, and focus on mandatory skills than desired skills, and slowly keep on adding the desired skills also so that you stand out in the competition. Okay, so the question from Jiva is, could we expect in-depth knowledge on HBase from you in future? Please let me know if you have any idea on that. No, I don't. I might not focus a lot on HBase. You have to build those skills on whatever I have explained. The reason why I'm not getting too much into HBase or Cassandra is they are mostly application developer skills. For data processing, people don't use HBase or Cassandra that much. But from the application perspective, they need to have much in-depth knowledge from programming perspective. For example, if you want to build a recommendation engine out of the data that is being stored in HBase or Cassandra, you need to know the other programming constructs of the underlying technology you are trying to use. HBase or Cassandra are simple tools. They only have those basic capabilities, operational capabilities. It's all about the programming language surrounding it, how you use APIs to connect to those things and get the information out of it. If you are using Spark, Spark has the same way as you can write it to a database table or into a file system, there will be a Cassandra related APIs or HBase related APIs. You just have to use it and you can write the data into those things after processing the data. So you just need to understand those APIs. It's not very complex, and I'm not going to cover anytime soon on those topics. Probably if any one of you are interested, once you gain the experience, you can start contributing by writing blogs and all those things on my platform. But personally, I might not focus on HBase very extensively. Whatever I have covered, only that is the part which will be covered. And that is more than enough. It's more about how you use HBase, and based on that, you need to explore further. Again, when you go to the dice.com and look for big data engineer, there will be required skills and desired skills. You have to focus on the required skills and the emphasis. You have to interpret each and every line in the job requirement. Even in required skills, there will be a lot more emphasis on some skills over other skills, and you have to prioritize accordingly. Don't give equal weightage for each and every technology they mention in the job requirement. You have to understand, you have to spend enough time to interpret the job description, and based on that, you have to prepare. And HBase, Cassandra, all these are small components, especially from the data engineer perspective. First thing is you need to understand either MapReduce or Spark or both. Second is the Hive. Third is Scoop. And fourth is how you can actually build applications around those things. And then you can actually focus on NoSQL. It's way behind in the priority than others. Okay, thank you. And keep me posted if you get a job, if you guys get job in big data. I didn't teach these live classes to volume. Hardly 50-60 people are there. I have ran one large batch of 50-60 people, but I didn't get any feedback whether they have migrated or they have shifted to big data or not. Most likely they might not, because they are already in a good technologies like Oracle DBS. Some of them are Oracle DBS, some of them are Oracle ERP DBS, some of them are Oracle ERP developers. And when you compare from the monetary perspective, you will not see immediate benefit when you go to the full-time roles with respect to big data. Most of the people are forced to stay back in the current technologies, because when they see the real picture, especially in the US job market, they don't get 30%, 40% hike that easily. Okay, even after putting so much of effort and learning these newer technologies, they might get 10% or 15% hike only if they have to go to full-time jobs. When it comes to contracting, um, people are a little bit reluctant to switch the technology and start on new project, because on contracting you have to start performing on the day one itself. So even though I trained 100 or 150 people overall, most of them haven't switched to big data yet. But there are few people who learn for free through my channel, website, etc., and they are working in big data. Some of them are working in big data. So please acknowledge if you get jobs in big data, especially Jiva, as you are pretty early in your career, and as you have that opportunity to take the chance and get into the big data. If you get a break in big data, let me know. It's the case with anyone else. You might not transition immediately, but start using my lab as much as possible and stay tuned with the technologies and jump on the ship whenever you get an opportunity. Don't give up in the middle, because big data is going to stay here. It's an open source technology. It might not make significant difference to your paycheck immediately if you have 10-year, 12-year experience, but over a period of time, whoever does not transition to this open source based technology ecosystem, they will struggle to continue the momentum. When they switch to big data or cloud, they will be able to have some momentum for some more time. In general, IT is saturated. You will not see significant hikes going forward. Okay. Sure, I will definitely work on Spark streaming. So as I have explained to you earlier, the workshop of Kafka is about getting the data in real time from source system using Flume. Use Kafka as a queue in between, port data to Spark streaming or some streaming technology, and then store into HDFS or whatever database we want to store. So it's an end-to-end life cycle which I will be covering, and I will try to get into a few more details as part of that course. It could be a good foundation for you, and then you can try out and you can explore more and you can gain some more knowledge. Okay. Okay, then thank you very much for attending the session. I'm very glad. This is, I can say, my second most successful session. I didn't take so many batches. The first most successful is the one which I have spoken earlier. I have 50 people in a single batch for a company, and it was quite successful. And then this is the second most successful live batch. And going forward, I will only take one batch every quarter live, so that I can spend time on other technologies and keep on creating content for my LMS platforms. That being said, best of luck, Venkat. Let me know the feedback. If we can discuss, irrespective of the outcome, we can discuss how it went, and we can see how we can get better at it going forward. Best of luck anyway. I hope you will get it in the first attempt itself. You have all the required background and skills and certifications, so it should be easier for you. Okay, then. Thank you very much for attending this session, and have a nice day. Bye. So people who are on my YouTube live, thank you very much for joining the session. I will announce my future live sessions. If you are interested, you can fill the interested form. I will conduct few kickoff sessions before starting the session. Otherwise, you can actually sign up to my LMS platforms and start learning for free as well. So there is one question from Naresh. I am new to Hadoop. Tell me in real time what is cluster size in companies, what configuration they use in nodes, and RAM size and everything. Please tell me. I am attending interviews. I cannot tell all those things in detail. You have to follow my videos and you have to learn them over time. Then only we'll be able to effectively communicate to those things. I don't tell, and and depending upon the scenario, it will vary. It's not that everyone use the same type of cluster. You have to visualize those scenarios, and you have to be prepared with the answers. Okay. Okay, then. Thank you very much, and have a nice one. Whoever is on YouTube Live also. If you like this session, please click on the like button. It is over here. Please provide the feedback in the comment section if you want to provide the feedback after the live chat is disabled. And stay tuned. Subscribe to my lab, and subscribe to my channel, and learn these technologies for free. Thank you. Bye.